is Ramses from the Toorn, born 1967. I'm an assistant professor in a group of mathematical physics, which is part of the Department of Applied Mathematics of Delft University of Technology, and I proudly run this course on differential equations for aerospace engineering. So this is 2020. Early this year I was involved in coaching mathematics students for their modeling course, and some of those students were modeling the COVID disease that had then just been observed in China. But before that quarter ended, COVID took over the world, societies had to be locked down, the university was closed, and the coaching had to be done from home by online tools. And the disease is still here. It's still around and we have to deal with that. And for that reason, this year's edition of the course on differential equations for aerospace has to be online.
Late August, South Holland Beach, 25 kilometers north of the entrance of Rotterdam Harbour. For the birds at the beach it is business as usual. But this shot is not about birds. Large passenger cruise ships have been anchored just off the Dutch coast. This is 2020, and COVID-19 has put passenger cruise ships on hold. They have been here for months now. This is Amy, Amazon Web Services, reporting back to course WI 2180, LR1, from South Holland Beach Camp.
So I work from home, I do the recording at home, that has also its advantages. I have my books, so I have all the material that we need to do this. It might explain that you might hear occasional sounds from the environment, like gulls. We have quite some birds around. I live nearby the sea. Occasionally you hear other sounds, chatting. Just a thought, a bit philosophical maybe. That's what you get in a place like this. But it's about why differential equations play such a central role in the physical sciences, the applied sciences, and in engineering. If you look at the world around you, it's very, very rich with its shapes and processes, changes that you observe. Mankind has always tried to understand the world around us, and at the large level it's very rich, complicated maybe, but if you zoom in on the water, maybe zoom in on a small scale, you no longer see all these rich shapes, but you concentrate only on a little amount of water. You can also zoom in over time, study that little amount of water over small amounts of time. And the spatial structures that you see are easier because you have zoomed in on a small part. And the changes over time also become easier because in little time the change is also small, so easier to describe. It might explain why mankind has succeeded formulating the laws of physics on small scales over small amounts of time. Mankind has succeeded to find the patterns that rule the world there, those scales. And differential equations is little else than that. It's what they do. They describe relationship between changes. So that might explain why the laws of physics have come to us in the form of differential equations, because complicated as the subject might seem, after all, at a small scale, it's easier than describe the whole world at once at the macroscopic scale. And then solving differential equations is the technique, the attempt to arrive at conclusions on the larger scale, starting from the rules that you formulate at the smaller scale. So that is what the course is all about. So for this year, for the online edition of the course, our platform for communication will be Brightspace, the website, where you will find the lecture schedule that outlines per week, per lecture, the material that we shall cover, and also indicates the types of exercises that would be appropriate for that lecture. You will find lecture slides, notes, an exercise collection that has selected exercises with workouts that I provide. The lecture instructions and explanations themselves I will try to make available as much as possible in the form of recorded video material. That is new, that has to be developed. So I'm proceeding with that as we go along, and I am still exploring different styles of making such videos to arrive at the best option for each subject and each style of material. The textbook that we will use is Boys in the Prima, Elementary Differential Equations and Boundary Value Problems. I have, most of you will have the 11th edition or the 10th edition. I have the 4th edition here. This is my copy from which I learned the subject a great number of years ago. Nothing changed much content-wise. But every new edition there are some changes in the order of the exercises and sometimes some numerical details in the exercises. So I will not refer to exercises by their exact numbers, because those depend on the exact edition, but I will rather refer to exercises by subject and by the goal that we have with that. I will do so by providing worked out examples, and then if you want to do more exercises you can find them yourself in the corresponding sections in the book, and the answers are at the back. The worked out examples in the main text are always useful, then you have a workout. I think the way to go with such a textbook is not so much to read it from front to the back for yourself, because we cover a great deal of the material, but not everything, and we have a specific focus. So let me be your guide, pointing out the highlights and I will connect those. And then, so follow my lectures and follow step by step the examples in the exercise collection. So you have the focus and become aware of the highlights, and then look it up in the textbook whenever you need it to read the story from maybe a little bit a different phrasing or a little bit different perspective. But work backwards. So start with the lectures, my videos, slides maybe, things that are in the exercise collection, and then go back to the textbook, find the corresponding exercises and read about the theory according to your needs to fill your needs. Yeah. So a remark on the level of this course, that is ambitious, but this is aerospace, and there's a saying, if something is not very difficult, people say it's not rocket science, but aerospace is more than rocket science. So there we go. So the level of the course is ambitious, both in volume, the amount of material that we have to cover, and also in the end level that we have to reach. That's ambitious, and that has consequences. I've been running this course for a couple of years now, and I'm very aware of the end level that we have to reach. And my solution for that is to start right in the beginning, to here and there, whenever needed, to make a little bit more depth, put things in a wider perspective, wider than you would do if you would cover those early subjects separately, only for themselves. And that is because it is a good investment. If we start doing that and operate that way right from the beginning all the way through the course, we build up ingredients that we can combine together to a coherent picture at the end, and that will make the amount of material shrink, because a coherent picture is easier to conceive and understand than kind of patchwork of all kinds of loose techniques and tricks. So making a little bit more depth and adding perspective in the beginning will turn out to be a very good investment, and that will help us to reach the level that we need to reach in the end. It also explains why the modules of this course are not interchangeable with modules of other courses that are given at other faculties at the university. So it is really a coherent story, so to say. You will see that different instruction and lecture videos will have different styles. Some will be based on the PowerPoint presentations that we used to have for the live sessions in the lecture halls. So I can just demonstrate those on my laptop and record a voiceover. The same things that I would say if I would be lecturing in a live hall. So that would be PowerPoint and my explanation as a voiceover recorded as a video. Another type of working is doing demonstrations by pencil and paper. That is what I would do in a hall on a chalkboard, so to speak. It may not look that pretty as a printed book or a PowerPoint, but I do it on purpose because I do want to demonstrate what a mathematical derivation looks like if you do write it on paper, because that is exactly the way that you would do if you make an exam or if you do exercises for yourself. You have your sheet of paper and you write your mathematical derivation, your theory, your solution of problems by hand. And I do want to demonstrate what it looks like. And that is also the reason why I have my paper in portrait mode, while for video it would be more suitable for the screen to have it in landscape. But portrait is what you have on your desk. And I think it is appropriate to demonstrate what it would look like for you, how you would do it yourself. So do take it as a demonstration, and if you exercise, take my demonstrations as an example. They also demonstrate the amount of details that you need to document your answer in an exam setting. So you do not have to write more than I do, but I'm quite minimalistic in my documentation, and that is, I think, why you need a voiceover. You need my explanation when you first read my demonstrations, so that is why the video recordings are good for. I will also post copies of the completed workouts of those demos. So if all goes well and you have understood it, you should be able to read those workouts for yourself afterwards, after you have learned to read them by studying my video material. I think the demos will be pretty quick. I go through it probably faster than you could follow. And I think that is a big advantage of having a video recording. So use it, use your pause button, and use the possibility to go back and watch and listen to phrases and passages and fragments over and over again until you understand what I say, understand what I write, the order of it, etc. So I imagine that to study a 20-minute video in that way, you might need, if we make some depth in theory, if it is really an in-depth explanation of a piece of theory, you might easily need, with breaks, an hour or more to really understand and learn what can be learned from such videos. So the lecture videos will be shorter than a true lecture, because they are really dense and compact. I explain carefully, but to understand and follow you probably need to pause, go back, study, really study. It is not, it is intense material, so keep that in mind if you study my demonstrations. As regards videos in which I will do some in-depth explanation of theory or a detailed demonstration of how to solve exercises or problems, I will likely more than once do that writing on a piece of paper, like what I will do in a live lecture on the chalkboard. And I will have the paper like you would have it yourself on your desk, so in portrait mode instead of landscape. And that's on purpose, because I'd like to do it like you could do it yourself, and also in the exam situation you write on your paper in portrait mode. So I will write the derivations and explain it and video that, so you see how it builds up over in the course of the process. Still, I imagine that it can be quite dense, and then we should take profit from the video medium. where you have your pause button and you can go back and study passages over and over again, listening to what did he say, why does he write this, how does this relate or follow from what was written and said before. So you can study it quite in detail. So I imagine a video fragment in which I explain a new topic could take like 20 minutes, 25 minutes or so. But studying it in detail, using the video tools that you have, the pause button, go back, might take you easily the full period that normally a lecture takes, so like 45 minutes or maybe even longer. So keep in mind that I have in mind when I do it that it is quite dense material, but I dare to do it that way because I do know that you have a pause button and the rewind button. So keep that in mind. So here we go, 2020 edition of the course on differential equations for aerospace engineering. Apart from the online material that I will make available as downloads from the Brightspace website, I will also set up interactive ways of working, of course. We can use virtual classroom, we can set up email communication to which I will respond. As I said, I'm quite proud to run this course. I've been running it for a couple of years now. It has always been a pleasure and given me great pride. So I'm really looking forward to meeting you somehow online as active participants in this adventurous course on differential equations for aerospace engineering.